PVC is not suitable for electrical wiring because it is a plastic material not rated for conducting electricity, and it can become brittle over time, posing a safety hazard. The National Electrical Code (NEC) requires that electrical wiring be installed in approved raceways, such as conduit or electrical cable. To properly wire the water heater, install a conduit or electrical cable between the water heater and the breaker panel. Use THHN or XHHW wires rated for outdoor use. Protect the wiring from sunlight and weather conditions by using outdoor rated conduit or cable. Install a 15-amp breaker in the breaker panel to protect the circuit. The conduit or cable should be appropriately sized for the wire gauge and number of conductors being installed. All wiring connections should be made in approved electrical boxes and properly secured. It is recommended to hire a licensed electrician to perform the wiring to ensure compliance with code and safety standards. When installing electrical wiring, safety is paramount. Understanding the properties of different materials is crucial. PVC, or polyvinyl chloride, is a common plastic used in plumbing and various other applications, but it is not designed to conduct electricity safely. Using PVC as a conduit for electrical wiring can lead to serious hazards, including electrical shocks and fires. The NEC sets the standards for safe electrical installations. These standards are in place to protect people and property from electrical hazards. Following the NEC is not just a good practice, it is the law in most jurisdictions. Approved raceways, such as conduit or electrical cable, are designed to contain and protect electrical wiring. Conduit provides a rigid, protective pathway for wires, while electrical cable is a flexible assembly of wires enclosed in a protective jacket. THHN, or thermoplastic high heat resistant nylon, and XHHW, or cross-linked polyethylene high heat resistant water resistant, are types of wires commonly used for electrical installations. These wires are insulated to prevent electrical shorts and are rated for specific temperature and environmental conditions. When installing electrical wiring outdoors, it is essential to use materials that are rated for outdoor use. Outdoor rated conduit and cable are designed to withstand the elements, including sunlight, rain, and extreme temperatures. These materials are typically made of UV-resistant plastics or metals that will not degrade over time. The size of the conduit or cable depends on the number and gauge of the wires being installed. The NEC specifies the minimum size requirements for different wiring configurations. Using the correct size conduit or cable ensures that the wires are properly protected and that there is enough space for heat dissipation. Electrical boxes are used to enclose wiring connections. These boxes protect the connections from damage and prevent accidental contact with live wires. All wiring connections should be made inside approved electrical boxes and properly secured with wire connectors. A circuit breaker is a safety device that protects an electrical circuit from overcurrent. When the current in a circuit exceeds the breaker's rating, the breaker will trip, interrupting the flow of electricity. Installing a 15-amp breaker for the water heater circuit provides protection against overloads and short circuits. If you are not familiar with electrical wiring, it is best to hire a licensed electrician to perform the installation. Electricians have the training and experience to ensure that the wiring is done safely and in compliance with the NEC. Working with electricity can be dangerous, and it is important to take all necessary precautions. Always turn off the power to the circuit before working on any electrical wiring. Use insulated tools and wear appropriate safety gear. Double check all connections to ensure that they are tight and secure. A properly installed electrical system is essential for the safe and reliable operation of electrical equipment. By following the NEC and using approved materials and methods, you can help to prevent electrical hazards and ensure the safety of your home or building. Remember that electrical codes can vary depending on your location. Always check with your local building department to ensure that you are following the correct codes and regulations. Obtaining the necessary permits before starting any electrical work is also important. Permits ensure that the installation is inspected by a qualified electrical inspector and that it meets all applicable safety standards. Continuous learning and staying up to date with the latest electrical codes and technologies are essential for anyone working with electricity. Consider taking continuing education courses or attending industry events to expand your knowledge and skills. Safe electrical practices are crucial not only for your own safety but also for the safety of others. By following the guidelines outlined in the NEC and seeking professional help when needed, you can contribute to a safer electrical environment for everyone. Always prioritize safety and take the time to do the job right. Shortcuts and improper wiring can have serious consequences. Regular maintenance and inspections of your electrical system can help to identify and address potential problems before they become hazards. Check for loose connections, damaged wiring, and other signs of wear and tear. Replacing outdated or damaged electrical components is important to maintain the safety and reliability of your electrical system. Consider upgrading to newer, more energy-efficient equipment to save money and reduce your environmental impact. Educating yourself and others about electrical safety is an ongoing process. Share your knowledge and experience with others to help promote safe electrical practices in your community. By working together, we can create a safer electrical environment for everyone. When selecting a conduit for electrical wiring, several options are available, each with its own advantages and disadvantages. Firstly, rigid metal conduit, or RMC, is a heavy-duty conduit made of galvanized steel or aluminum. It provides excellent protection for wiring and is suitable for both indoor and outdoor applications. RMC is often used in commercial and industrial settings where durability and strength are required. Secondly, electrical metallic tubing, or IMT, is a lightweight conduit made of galvanized steel or aluminum. It is easier to bend and cut than RMC, making it a popular choice for residential and light commercial applications. EMT provides good protection for wiring and is relatively inexpensive. Thirdly, flexible metal conduit, or FMC, is a flexible conduit made of steel or aluminum. It is used in situations where flexibility is required, such as connecting to motors or other equipment that may vibrate or move. FMC provides limited protection for wiring and is not suitable for wet locations unless it is liquid-tight. Fourthly, liquid-tight flexible metal conduit, or LFMC, is a flexible conduit made of steel or aluminum with a liquid-tight jacket. It is used in wet locations or where wiring may be exposed to oil, grease, or other liquids. LFMC provides good protection for wiring and is resistant to corrosion. Fifthly, non-metallic conduit, or PVC conduit, is a lightweight conduit made of PVC plastic. It is resistant to corrosion and is suitable for underground or wet locations. PVC conduit is not as strong as metal conduit and may not be suitable for all applications. When selecting a wire for electrical wiring, several factors must be considered, including the amperage rating, voltage rating, and environmental conditions. Firstly, THHN wire is a common type of wire used for general-purpose wiring. It has a thermoplastic insulation and a nylon jacket, which provides good protection against moisture and abrasion. THHN wire is rated for 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. Secondly, THWN wire is similar to THHN wire, but it is also rated for wet locations. It has a thermoplastic insulation and a nylon jacket that is resistant to moisture and oil. THWN wire is rated for 75 degrees Celsius in both dry and wet locations. Thirdly, XHHW wire is a high-temperature wire with a cross-linked polyethylene insulation. It is rated for 90 degrees Celsius in both dry and wet locations. XHHW wire is often used in applications where high temperatures are present, such as in industrial settings. Fourthly, UF wire is an underground feeder wire that is designed for direct burial in the ground. It has a solid thermoplastic insulation that is resistant to moisture and chemicals. UF wire is typically used for wiring outdoor lighting, pumps, and other equipment that is located underground. Fifthly, USE wire is an underground service entrance wire that is used to connect the utility company's service to the building's electrical panel. It has a solid thermoplastic insulation that is resistant to moisture and chemicals. Use wire is typically used for underground service entrances. The NEC provides tables that specify the ampacity of different types of wires. Ampacity is the maximum amount of current that a wire can safely carry. The ampacity of a wire depends on its size, insulation type, and the ambient temperature. It is important to select a wire with an ampacity that is sufficient for the load that it will be carrying. Overloading a wire can cause it to overheat and potentially cause a fire. When making wiring connections, it is important to use approved wire connectors. Wire connectors are designed to provide a secure and reliable connection between wires. There are several different types of wire connectors available, including wire nuts, crimp connectors, and push-in connectors. Firstly, wire nuts are a common type of wire connector that is used to connect two or more wires together. They consist of a plastic cap with a metal insert that is screwed onto the wires. Wire nuts are available in different sizes to accommodate different wire gauges. Secondly, crimp connectors are used to connect wires by crimping them together with a special tool. Crimp connectors provide a strong and reliable connection and are often used in automotive and industrial applications. Thirdly, push-in connectors are a relatively new type of wire connector that allows wires to be connected by simply pushing them into the connector. Push-in connectors are easy to use and provide a secure connection. When installing a circuit breaker, it is important to select the correct size breaker for the circuit. The size of the breaker should match the ampacity of the circuit wiring. Installing a breaker that is too large can allow the circuit to be overloaded, which can cause a fire. Installing a breaker that is too small can cause the breaker to trip frequently, which can be annoying. Circuit breakers are available in different types, including standard breakers, ground fault circuit interrupter breakers, or GFCI, and arc fault circuit interrupter breakers, or RFCI. Firstly, standard breakers are the most common type of circuit breaker. They protect against overloads and short circuits. Secondly, GFCI breakers protect against ground faults. A ground fault occurs when current leaks from the circuit to ground. Ground faults can be dangerous because they can cause electrical shocks. GFCI breakers are required in bathrooms, kitchens, and other wet locations. Thirdly, RFCI breakers protect against arc faults. An arc fault is an unintentional electrical discharge between two or more conductors. Arc faults can be caused by damaged wiring, loose connections, or faulty appliances. RFCI breakers are designed to detect arc faults and trip the circuit before a fire can start. In addition to following the NEC and using approved materials and methods, there are several other safety precautions that should be taken when working with electricity. Always turn off the power to the circuit before working on any electrical wiring. Use insulated tools and wear appropriate safety gear, such as rubber gloves and safety glasses. Never work on electrical wiring when you are wet or standing in water. Be aware of your surroundings and avoid contact with overhead power lines. If you are not comfortable working with electricity, hire a licensed electrician to perform the work. A licensed electrician has the training and experience to ensure that the wiring is done safely and in compliance with the NEC. Electrical codes can vary depending on your location. Always check with your local building department to ensure that you are following the correct codes and regulations. Obtaining the necessary permits before starting any electrical work is also important. Permits ensure that the installation is inspected by a qualified electrical inspector and that it meets all applicable safety standards. Continuous learning and staying up to date with the latest electrical codes and technologies are essential for anyone working with electricity. Consider taking continuing education courses or attending industry events to expand your knowledge and skills. Safe electrical practices are crucial not only for your own safety but also for the safety of others. Share your knowledge and experience with others to help promote safe electrical practices in your community. By working together, we can create a safer electrical environment for everyone. Remember that electrical wiring is a complex and potentially dangerous task. If you are not sure what you are doing, it is best to hire a qualified electrician to perform the work. The risks of improper wiring are too great to take chances. Always prioritize safety and take the time to do the job right.